Hello everybody, I'd like to welcome you to our 29th video in the pre-algebra playlist, and in this video we're going to go in detail over the concept of fractions. Now before I discuss fractions in detail, let me go over a definition with you. That definition is that of a rational number. A rational number is said to be any number that can be written as a quotient of two integers a and b where the denominator is not zero. A rational number is basically any number that I can write in the form of a divided by b. In this case, I have two integers, one of them is the a and one of them is the b, given that the denominator is not equal to zero. So now let me go over a few examples of what rational numbers are. A number such as 2 over 3, or basically 2/3, is known to be a rational number. Another example of a rational number is the number 1/2. Similarly, a number such as 5 over 8 is also an example of a rational number. And lastly, any whole number is an example of a rational number. This is because in the cases of whole numbers, the denominator is simply said to be 1. So now let's go over the conceptual meaning of fractions. Just like decimals, fractions are used to represent part of a whole. You know by now that a fraction consists of two parts. On the top of the fraction bar, there is what is known as the numerator, and on the bottom of the fraction bar, you have the denominator. Now, there are many different ways of thinking about fractions, but the way I think about it is that the denominator represents how many equal parts of a whole there are, and the numerator represents how many equal parts out of that whole we are talking about. So for example, let's talk about the number 1/2 over here. 1/2 tells me that I have two equal parts of the whole, and I am dealing with one of those parts in my problem. So now many times in your math careers, your teachers or your standardized tests will ask you to figure out answers in terms of a fraction. Now if I give you something such as 16 over 4, that is the same thing as saying 4, because that is the same thing as saying 16 divided by 4, and when I do that, I get 4. Sometimes you end up dealing with numbers such as 5 over 8 or 2 over 3. In these cases, you are not really able to do long division efficiently in the given amount of time. So the best way to deal with these types of answers is to basically leave them in terms of a fraction. So now on the next page, I'm going to go over methods that will help you solve or basically reduce fractions in their lowest terms. Many times you will be asked to simplify fractions. So what do they mean by that? Well, let's say you have some number such as 2 divided by 4, and you want to simplify this fraction into its lowest possible terms. The first thing that you need to do is figure out the prime factorization for the numerator, and then figure out the prime factorization for the denominator. After that, you need to cancel out the common factors from the numerator and the denominator. So what do I mean by this? Well, let's do this example over here. I know that the prime factorization of 2 is just 2 because 2 is in itself a prime number. For the denominator of 4, I know that the prime factorization for 4 is simply 2 times 2. Now we need to look a few videos back and realize that when we were solving equations, we learned a property that said that if I have some number a, and if I divide that some number a by another number, which is a, then that will give me an answer of 1. So basically, if both the numerator and the denominator are the same, then I will get an answer of 1. So I can rewrite 2 divided by 2 times 2 as simply 2 divided by 2 to the power of 2. Now referring back to the exponents video, this right here is the same thing as saying 2 to the power of 1 minus 2. And that is the same thing as saying 2 to the negative 1. You also know that when you have a negative power as an exponent and you want to get rid of that, all you really need to do is put this whole number below the number 1. So 2 to the power of negative 1 is the same thing as saying 1 over 2 to the power of 1. So this right here, 2 divided by 4, is the same thing as saying 1/2. Let's do one more example. Let's say if I have some numbers such as 16 divided by 48, and I ask you to simplify this number into its lowest possible terms, Then the first thing that we need to do is figure out the prime factorization for the number 16. In this case, the prime factorization of 16 is 2 to the power of 4. The prime factorization for 48 is as follows. So I first need to deal with the 2 to the power of 4 on the top and on the bottom. We learned over here that that is the same thing as saying 1. So this right here cancels out to give me 1. Now, since the number is 1, it doesn't really matter if I put it on the top or the bottom. So this right here is the same thing as saying 1 divided by 3. Let's say you have some numbers such as 54 divided by 21. The following is a prime factorization for the number 54. And the following is a prime factorization for the number 21. So the first thing that I need to do is deal with the common basis. I have a 3 to the power of 3 on the top and 3 to the power of 1 on the bottom. When I simplify this over here, that gives me 3 to the power of 3 minus 1, which is the same thing as saying 3 to the power of 2. Now, if you're wondering where I would put this 3 to the power of 2, basically, would I put it on the top or the bottom? The answer is that I would put it on the top. Therefore, I put the simplified answer, which is 3 to the power of 2, on the top. And since I can't really do anything to the 2 and the 7 over here, because they're both prime and because they don't have the same basis so that I can simplify them further, my answer is simply 2 divided by 7, and on the top I also have 3 to the power of 2. This right here is the same thing as saying 2 times 9 divided by 7. And that is the same thing as saying 18 divided by 7. So 18 divided by 7 is the simplified form for the number 54 divided by 21. Let's do one more example where we simplify a fraction into its lowest possible terms. For this example, let's say I want to simplify some numbers such as 18 divided by 54. The first thing that I need to do is figure out the prime factorization for both the numerator and the denominator. The following is the prime factorization for the numerator. And the following is the prime factorization for the denominator. So let's first simplify the base of the 2. I have a power of 1 on the top and a 1 on the bottom. When I simplify 2 to the power of 1 divided by 2 to the power of 1, that is the same thing as saying 2 to the power of 0, or more simply, 1. Now to that, I multiply whatever the simplification of 3 to the power of 2 divided by 3 to the power of 3 yields. Now when I do 3 to the power of 2 divided by 3 to the power of 3, that is the same thing as saying 3 to the power of 2 minus 3. And that is the same thing as saying 3 to the power of negative 1. That is more commonly known as simply 1 times 1 over 3. And since 1 times anything is that anything, I really don't need to write 1 times over here. Therefore, my answer is simply 1 over 3. Now in the next video, we're going to go over how to add and subtract fractions. So I hope you keep on working hard, and I'll see you in the next video.